Assalamu alaikum students, welcome to our channel Study Time. Here today we are going to discuss physics, numericals, chapter number 2, vectors and equilibrium. Now without wasting our time, let's move towards the numericals. But don't forget to subscribe our channel, share our video, like our video and do press on the bell icon to get updated for more videos. Let's move toward the first numerical according to the shorts tables. The first numerical. Suppose in a rectangular coordinate system, a vector A has its tail at the point P -2, -3 and its tip at Q 3 or 9. Determine the distance between these 2 points. As they have told us, like the vector has a tail. Here is P -2, -3 and Q is here as 3 and 9, the values they have given us. This is vector A. Alright, they have told us that we have to determine the distance. Now the data that they have given us is P and Q. This data we have to write, and what we have to find is the distance R. Okay, now let's calculate. As R1 we have is this one, P, which is -2 unit vector I -3 with unit vector J. The second distance they have given is Q, which is +3 unit vector I plus 9J. Okay, now how to find the distance? The formula we have is R2 minus R1 vectors is equal to R. This is the formula we have. According to this formula, we're going to solve. Now let's start. R is equal to the R2 value we have to put over here, 3I plus 9J minus the R1 we have -2 unit vector I -3J. Now let's solve it. 3I plus 9J. We're going to multiply the minus with the values which are in the inside of the bracket, plus 2I minus plus 3J. Okay, now let's solve the I unit vector values and the J values. First of all, I, 3 plus 2, 5I, plus 9 plus 3 we get is 12 J unit vector we have. Alright, so this is the distance we get. Okay, now as we know that the distance between, they have told us to find the distance between these 2 points, P and Q. Okay, we have got is 5I unit vector plus 12 J unit vector. Now for this we also have to find the magnitude of R. The magnitude of R. The value for magnitude, the formula we use is R is equal to x squared plus y squared with square root. Now x squared we have is this 5 and y squared we have is 12. Let's put the values. R is equal to 5 squared plus 12 with the square with the under root over here. 5 square is 25 plus 1, 44 divided under root, sorry. Now we add these, we get is 169. And when we take the square root of 169, we get is 13 units. So the answer we get is 13 units. That's the magnitude of R. That's the absolute right answer. Okay, I hope you have understood the first numerical. Now let's move toward the third numerical. The second numerical we have is 2.3. Let's discuss the statement first. The statement we have is, what is the unit vector in the direction of vector A is equal to 4i unit vector plus 3j unit vector. Now in this, they have told us, let's move toward the second 2.3 over here. The data they have given is A is equal to 4i plus 3j. We have to find is the unit vector A. Now the formula we have it is for unit vector A vector divided by A magnitude. This is the vector. For this you also have to find the magnitude. So first of all, let's find the magnitude of this value. Magnitude defined is ax square plus ay square. It's under root over here. Now a square over here is 4. Let's put a value 4 square plus the y, that is 3 square with under root over here. That we have 16 plus 9 with under root is equal to 25. Under root is equal to 5. Now this is its magnitude. Alright, the magnitude we get is 5. Now we'll put the value in this formula and find it. How? Let's check. A unit vector, the data that is given to us. 4i unit vector plus 3j divided by the magnitude, which is 5. So the answer we get is this, because we can't solve further. So that's the answer, A unit vector. Alright. Now let's move toward the next numerical, which is 2.5. Let's discuss its statement. If a vector b is added to vector a, the result is 6 plus j unit vector. If b is subtracted from a vector, the result is minus 4 plus 7. What is the magnitude of vector a? This is the data that is given to us, and this is the magnitude which we have to find. Alright. Now let's solve it. Solution. Magnitude. First of all, they have told us that we have to add vector a to b, b to a, we get this, and by subtracting a with b we get this. The first step we are going to do is what? Let's check. A plus b, we're going to add these both. A plus b plus a minus b vector. You have to put the vector sign over it. Okay, means we're going to put the values and add these. The value of a plus b we have 6 I vector unit vector plus j unit vector plus a minus b, which is minus 4i plus 7j. Okay, I'm going to solve over here. 6i plus j minus 4i plus 7j. What you have to write over here is, when we open these values, we have plus with b and minus with b. These values, we will cut these, and these are plus, we will add these, and we get is 2a vector unit. 2a vector over here. This is plus and minus, so we cut these values. Now let's solve the I ones and the j ones separately. 2a. 6 minus 4 is 2. With unit vector and plus, we get as 8j. Now we're going to take 2 as common, or you're going to divide it. So we get is a vector is equal to I plus 4j. Alright, this is the a vector, we get it. Now we're going to find the magnitude of this a vector as told in the question. So the magnitude of this a vector is, with the formula we're using, x square plus y square. This is x1 plus y, that is 4, with under root 1 plus 16 the root is equal to 17 under root. When we take the under root of 17, we get is 4.1 units. This is the magnitude of vector a. Okay. Now let's move toward the numerical number 2.10. Here a is equal to I unit vector plus minus 2j unit vector plus 3k, and the value b is 3i minus 4k. Now let's discuss the statement. Given that a vector and b vector, now what we have to find is the projection of b on a. Now the projection of a on b means a cos theta. If they tell us the projection of b on a, it will mean b cos theta. Here we have to find is a cos theta. The formula we are applying here is a dot b is equal to ab cos theta. The dot product we are going to take. Now a cos theta is equal to a dot b vectors divided by the magnitude, which is b. Now when we put the values over here, we get is, I've put the value of a and b divided by the magnitude b, which is this 3 square plus minus 4 square with the square root. Now when we multiply, 3 ones are 3 minus 2, we don't have the value of j over here, so j will be 0. 2 multiply 0 minus plus minus here, 3 4s are 12 and k's are 1. Now here we're going to solve it. Now let's solve. We get is 3 minus 0 minus 12 divided by the under root of 9 plus 16 is equal to 25 under root, which is 5. Now when I solve it, 3 minus 12 is equal to 9 minus 9 here, due to 12, the greater number having minus, divided by 5. So the answer we have is minus 9 divided by 5. This is the a cos theta. This is the answer. Now the next numerical 2.9, show that the three vectors we have a, b and c are mutually perpendicular to each other. These are the values of these three vectors. Now what we have to prove if they are mutually perpendicular to each other or not. For this we have to find is A dot B, B dot C and C dot A. With all of them one by one we have to take the dot product so that we can determine either they are mutually perpendicular to each other or not. Now let's start with A dot B. Vectors is equal to, we are going to take their dot product, I plus j plus k. The dot product would be 2i minus 3j plus k. 2 ones are 2, and when we multiply I with each other we get is, when we take the dot product of I, that is 1. Minus 3, 3 ones are 3 with the 1 plus 1. Okay, now let's solve it. 2 minus 3 plus 1. When we solve this we get a 0. When A dot B is equal to 0, it means it is perpendicular. A dot B are perpendicular to each other. Now we're going to do is B dot C. Either all of them are perpendicular to each other or not. B is 2i minus 3j plus k. With the dot product with C, 4i plus j minus 5k. Let's solve. 4 2s are 8 with the 1 minus 3, 1 minus 5, and kk is equal to 1. 8 minus 3 minus 5 is equal to 0. It means that B dot C is also equal to 0. Now is C dot A is equal to 0? Let's see. C we have is 4i plus j minus 5k, with A that is I plus j plus k unit vectors. 4 ones are 4 and I is equal to 1 plus 1 minus 5, 1. 4 plus 1 minus 5 is equal to A. It means that A dot B is equal to B dot C is equal to C dot A is equal to 0. It means all of these vectors are mutually perpendicular to each other. It is right. We just have to prove it by showing them these values. We have to multiply and show them. It means that A dot B is equal to B dot C is equal to C dot A vectors is equal to 0. It means that we are mutually perpendicular because the mutual scalar products are 0. Okay. Now the next numerical we have is 2.14, which is the last numerical. And let's read the statement. The magnitude of dot and cross products of two vectors. One vector is 6 under root 3 and the second vector is 6 respectively. Find the angle between these vectors. First it told that the magnitude of the dot product, which is A dot B, is equal to this, and the magnitude of A cross B is 6. We have to find the angle, which is theta, between these two vectors A and B. Okay, as we know that A dot B magnitude, so here A dot B vector magnitude is equal to AB cos theta, which is equal to 6 under root 3, and A cross B is equal to AB sin theta. We will open these values, which is equal to 6. Now what we are going to do is divide the equation 2 by 1 like this. AB sin theta divided by AB cos theta. Will you put the values? 6 divided by 6 under root 3. We cut these 6 and we get is 1 over under root 3. Okay, A cross B magnitude divided by A dot B vectors magnitude, and we get is 1 over under root 3. As we know that here we're going to cut AB because they are same, so we get is sine theta over cos theta, which is equal to tan theta, which means that over here what we're going to write is that tan theta is equal to 1 over under root 3. So what we want to find is theta only. So theta is equal to tan inverse is equal to 1 over under root 3. We have to find the tan inverse of 1 over under root 3. So when we take the tan inverse of 1 over under root 3, we get the answer is 30 degree, which means that theta is equal to 30 degree. By this solution we get the answer, and that was the last numerical, and thanks for watching our video.